Occurs when the output values demonstrate a repeating pattern. That's called periodic. So, a real life example of something that's periodic are the tides. Because what happens with the tides in the ocean? You get high tide, low tide, high tide, low tide. And it just keeps repeating over and over again. That's what we mean by periodic. The period is the length of the repeating section. So in terms of the tides, I'm not an expert oceanographer, but I'm going to say it's about like 12 hours. High tide to low tide, back to high tide again. Look at the picture. Then here is number 1. Function F. It has a period of 4. Now, does that make sense to you when you look at that picture? Would you agree that the period is 4? How many steps do we take before we start repeating again? 4? Draw 2 more periods. Okay, so go ahead and right there on that graph, draw 2 more sets of 4. Just attach it right on. 2 more sets of 4. Got it? Compare your answer with your neighbor. Let's make sure that you match. Your trigonometric functions, which is what Unit 3 is all about, sine, cosine, tangent, they're periodic. That's why we're starting with this conversation. They are periodic functions. Okay, look at example 2. What is the least possible value of the period of G? In other words, if you had to draw G, what would be the shortest segment that you could draw that would represent function G? It's periodic. You could keep going. You could draw miles and miles of it. What's the shortest chunk? How many units? 5. 5. I want you to look at it. Make sure this makes sense to you. It's real simple. The curve consists of a horizontal line and then a triangle, right? And then it starts over again with a horizontal line and a triangle. Each of those little chunks, horizontal line, triangle, is 5 steps. So the period of this thing is 5. Could the period be considered to be 10? Does it repeat every 10? Yes. Could the period be 15? Yes. But in general, we always want the shortest period. So the shortest period is 5. All right, now, can you find the value for 14? Notice that your graph only goes up to 9. Could you continue drawing the graph? Yeah, but I really don't want to do that because, like, the next one is 72. Okay, I really don't want to do that. I don't want to draw more of it. Can we figure out what's going to happen at 14? How? Yes, you're right, we can. How? Every 5, it repeats, right? So would you agree that G of 14 will be the same as G of 19, or the same as G of 9, 4 the same as G of 4. Would you agree with that? Yeah, that's what makes periodic things so cool, is we know exactly how it's going to behave. So what's the answer to the question? G of 14 is 7. All right, what about 72? G of 2, Joe Funk. Why?
Because from 7 is divisible by 5.
So this is 2 plus 14 fives. And every 5 just repeats. So 14 of those, I can disregard them. And the answer to the question is 6. How about negative 17? What's G of negative 17? 7? G of negative 17 would be the same as, well, add or subtract 5, so G of negative 12, G of negative 7, G of negative 2, G of 3. Is that 7? Yep, it sure is. Perfect. Now, look at example 4. What if we don't have a picture? Now we have a chart. We are told that this thing, whatever it looks like, is periodic with a period of 5. So every 5, it repeats. So we have to somehow figure out, this is all we have to figure out h of negative 2. Now remember, every 5, it repeats. So won't this be the same as h of 3? And h of 3 is 0. Now, it's the same as h of other things. I'm just trying to get values that I have in my table. All right, h of 6. Take a minute, see if you can figure that one out. What's h of 6? Julia? Negative 2. Because again, h of 6 would be the same as h of 1. Because the period's 5. So we add 5 or subtract 5. Right? Easy. All right. Do C on your own. H of 9. H of 9. Got it? What do you think? Got 0 as your answer? Let's check it out. H of 9 will be the same as H of 4. Do I have that one? Yep. So H of 9 is 3. And then H of 3, taking this and plugging in here, H of 3 is 0. Perfect, perfect, perfect. What about D? What do you think? Looks hard, but it really isn't, is it? Because what do we mean by this? Isn't that the same as -3 plus 5k? And what is this? This is just adding periods, adding 5, 10, 15. So isn't that kind of not important? And we're just finding h of -3? Oh shoot, it's not up here. So what's h of -3 gonna be the same as? H of 7, which is got it? In a moment, you're going to get to practice some on your own, but let's get through these notes first. Example 4. Okay, that's just notation. Okay, example 5. The graph of F is periodic with the domain all reals. So in other words, it just keeps on going forever and ever. 2 full periods are drawn. Find all input values that yield an output value of 1. All right, well, just looking at the picture, f of what gives me 1? What is the number? 2 would give me 1. What else? 6 would give me 1, because the period of the thing is 4. So I somehow have to list all these. So 2 and 6, wouldn't 10 also give me 1? There's lots of them. How am I possibly going to list them all? Come on, you know this. We're starting with 2. And what are we doing? We are adding or subtracting multiples of 4. So maybe 4n. And n is, if this is the way you set it up, n would be a whole number. So 0, 1, 2, 3. That's what you're adding and subtracting. Multiples of 4. So this would describe all of the inputs that give you 1.
What is that?
Is an element of, n is an element of a set of whole numbers. You can't just throw in an n without describing what is n. What are you talking about? What's n? It is a whole number. Now, you could, you might see this, but then n would have to be an integer because you have to account for the negatives. So that would be exactly the same thing. Okay, finally, example 6. Okay, read the problem, figure out what the heck is going on. Okay, would you agree this thing is a periodic phenomenon? Yeah, the clock's going around. So the distances from before are changing. In the beginning of the problem, when time is 0, the clock hand is straight up. So how far is the tip of the hand from the floor? 128 inches? And then that happens again 30 minutes later. Would everybody agree with that? Now, what's happening in the middle here? Well, where is the hand after 15 minutes? Straight down? So how far is it from the floor now? 112. Where is it after 7.5 minutes? Over here? How far from the floor? 120. And again, at what, 22.5 minutes, it's 120 above the ground. And then it repeats. So if we graphed it, we would get this wavy line. If we graphed those numbers, we're going to get this wavy line. Actually, he doesn't really have a grid set up. So can we label these points? F and G and J and K and P. What do you think? What do you think would be a possibility for point F? 0, 128. Absolutely. And then this guy over here is 30, 128. And this guy right here is 15, 112. 7.5, 120. And 22.5. Now those are possibilities. Certainly there could be others because this thing is just going to keep going. But those are possibilities. T, where's G? Okay, so we're looking at this point and this point. Question B. What can you say about your picture, your function on that interval right there? Which of those is true? C? Now I want you to be careful. What is H? H is function. And what does H tell me? Like T is time. What is H? Distance from the core. Is H negative? No. So again, you're getting things confused. You're looking at your picture and you're saying it's going down. That's okay. That means the rate of change is negative. But that isn't what the question says. It says, tell me about the function. Tell me about the y values. The y values are positive. Now, what else? H is positive. Is H increasing or decreasing? Decreasing. The answer is B. The answer is B. H is the function, the height. It is positive and decreasing on that interval. On this interval, it's positive and increasing. The height is increasing. So describe how the rate of change is changing. How is the rate of change changing? The rate of change is negative and increasing because it's concave up. Beautiful, beautiful, beautiful. All right, turn to the back of page 3. Check your understanding. So they graph the height of the tide. How is the water level changing throughout the day? Just describe. Up and down. Higher, lower, deeper, more shallow. Determine the period of the function and interpret your answer in context. What's the period of the function? Be careful. 12. How far is it from either top to top or bottom to bottom, whichever's easiest for you to look at? Isn't the period 12? Don't we repeat ourselves every 12 hours? So what does that mean? We have a high tide every 12 hours or a low tide every 12 hours. What do you expect the water level to be at 33 hours? What? 4 feet? Or is that feet or inches? Feet, I guess. How did you get that, Oscar?
I saw that 36.
Okay, go ahead.
No, I kind of like forgot how I got it.
Okay, well, I think you're on the right track. If we know that the period is 12,
Yeah.
then whatever happens at 33 is going to happen at 21
Yeah.
and at 9 and at -3 if I had -3. But anyhow, so yeah. So what happens at 3? At 3, I'm at 4. You're right. So whatever logic you had, it was fine. I don't know what you did. At which time is the water level changing the fastest, and how do you know? This is a review question. Oh, come on, somebody remembers. You have the maximum rate of change, the fastest rate of change when the concavity changes. In other words, at the points called points of inflection. So where are your points of inflection? Points of inflection are not at 6.
9 and 15.
We got one at 3, we got one at 9, we got one at 15. So in other words, every 6 hours, that's when your rate of change is changing the fastest. All right, got a little group exercise for you. So I want you to partner up in your pods of 4. And let's crank this out. You guys are back here with them. You guys are moving over here. You guys are together. You two are just gonna fly solo. Back here with these guys. You guys are together here.
You might, you have an extra one for that.
Here's one.
All right, let's go. And we're gonna put some answers up on the board. You are. So work with your group.
Four.
What did I get?
The first one.
Oh, there's one.
Oh.
Period. So period. Uphill is hill and down. So period.
I know how to.
Yeah.
It's just zero.
Yeah, so it's
So, because this is like, it's going to be 2, so I would add 2, which would be negative 3 pi, and then 2 again, which would be negative 3 pi, and then on here, negative pi is 0. I'm just confused because I got 0 for the last one too. So that makes me
yeah.
I'm still so confused. It's like, just pretend that the pies are 1s. That's what I'm doing. It makes it a lot easier, because then it's like negative 2, negative 3 halves, negative 1, like negative 2, negative 1 half, negative 1, negative 1 half. Yeah.
All of them. Wait, I don't know. We have 2 times. No, you're right. I'm so lost.
It would be absolute value.
Okay, so yes, 5.
If this is not right,
Okay, so let me start over. Let me start over. Well, 10 divided by 2 pi to 10 pi. Okay, so
Four pi over 4.
even numbers would be.
Dude, to be honest, it's
It's 2 pi.
This is where I chat.
yeah, it is.
I don't know.
Because it just goes.
What if it's 1/4?
Oh my god, I'm so.
1/4 would be right here, so. Because if you add 2, that's 4/4. Or subtract 2, so then it would be 1/4, and that is 1/4 right here, which is 1. That makes sense. And then,
Don't ask me, ask each other. Yeah. Ask this group over here.
Yeah, I know you
He was lurking cameras in my
I was like, I can't tell.
What about TV?
this doesn't work and they were keys, so it makes me
Yeah. Probably.
Wait, but then that's 1. Oh wait. Okay, I don't know.
Yeah, but you have to like, don't you have to like, or was the other one subtracting like last time? Like, is this? Oh, okay, so then, wait, yeah, that actually makes
Yeah,
more
so
sense.
what's the difference?
So then,
Here, here's 5 and 5
oh, negative versus okay.
Oh, yeah.
Okay, wait. This is just a period of 10.
all the whole numbers.
Like the first one.
Oh yeah, they are all the whole numbers.
Would it be 90? Oh wait, if you add 10, it's 3. Yeah, it would be -2.
No, stop. We can't switch the answers in. Yeah.
Closest to the wall.
Because it would be 10 minus 10, and then 0 to 4. And then it's equal to 10 from 4, which is -6.
We're gonna stop the time.
Wait, so why? Oh, wait, no, never mind, I get it. Yeah, because it's periods of 10. Because the x plus 10 just means you add 10 plus 10 or whatever. Basically, just like
Actually, that might be.
do that. Because like if you were to multiply this like
All right, let's come together and kind of check what we've got so far. Who has an answer to number 1? What is the period of that picture? 4. I said 4, I hope you said 4. A period of the picture is a hill and a valley. Not just a hill. If it were just a hill, the picture would look like this. It has a hill and a valley, so the period is 4. Perfect. All right, what did you get for number 2, A, B, and C? Anna, what did you guys get? A, B, and C. 1, 2, and 1? You want to agree or disagree with that? 1, 2, and 1? Everybody's in agreement? All right. Number 3, what's the period of the picture in number 3? 9? What do we think? Are we in agreement there? 9? Okay, then A, B, and C. Emily, what'd you guys get for 4, A, B, and C? 2, -2, and 3. Are we okay? All right, now we've got another picture. And oh my goodness, the whining and complaining. Ooh, pies. Guys, get used to it because all your trigonometric graphs are going to look like this. This is a sine curve actually right here. This is a sine. Okay, so we have to get comfortable. The idea is the same. Doesn't matter that they're pies and not whole numbers. So, I have drawn one period of this picture. Because again, a period is a hill and a valley. So what is the period of the sine curve? 2 pi. The period is 2 pi. That means that every 2 pi, that thing will repeat itself. Pi for a hill, another pi for a valley. Put it all together, 2 pi. So, 0 to 2 pi, to 4 pi, to 6 pi, and so on. Okay, now, the function value right there at the origin is 0, right? And doesn't that same function value happen at 2 pi, 1 period later? And won't it happen again at 4 pi, and 6 pi, and 8 pi, and 10 pi? So I hope you said 0 for 6a. Now, what did you say for 6b? Also 0, because we have a 0 certainly every full period, but because of the way the thing's constructed, every hill and every valley ends at 0, right? So every pi we're at 0, beautiful. And what about 9 pi over 2? What did you say? Bryce says 1. What do you think? Is he right? Yes, because 9 pi over 2 is 4.5 pi. Would you agree with that? Take out 4 pi because that's just a period. This is going to be the same as 1/2 pi, which is right here. Good job. All right, number 7. What's the period in this one? Number 7, the period is pi. So this is another sine curve, but a couple of things have happened to it. It's been squished, and it's been moved down or downward, right? But it's still a sine curve. All right. Anybody get A, B, and C? I don't know how far you got. Anybody get A, B, and C for number 8? Raina, what did you guys get?
I don't. Wait,
We didn't get
I
that
think
far?
A is -1, -3, -1.
-1, negative
I was
3, -1. Is that what you said?
Yeah.
Okay. What do the rest of us think?
B is 1.
I'm okay actually with these two. Are you okay with these two? I'm not sure about this one. I need to think about this for a minute. Where is 5 pi over 4? Now, that would be 1 1/4 pi. Would you agree with that? So if I look up here, here is, this is a whole pi right here. That's 1 pi right there. Now, I would need to go 1/4 more. Or, since my period is pi, could I just back up and look at what happens at 1/4? What happens at 1/4? 1. Yep, that's a 1. Did any group get all those right? Yes. Good job back in the back. Great work. All right. Let's keep going. Let's get through as much as you can. We have a few more minutes. Not much. Let's get through a few more.
7, and then it's 7.
Pondering?
Yeah, I need to lock in.
How long is it?
So what'd you guys get for these?
Oh, -1,
Alright, group 1 up here, got number 9 already, -1, -1, 2, and 4. Anybody else get that far? Good on that? Alright, I want you to look at number 10. When they say that g of x plus 10 is g of x, what is that telling you? What piece of information does that give you? Period is 10, right? So this is just another way of expressing that we repeat every 10. So the period is 10. Good, let's see if we can get these up here. I haven't done it yet. All right, here is number, whatever that was, number 10. Anybody have a question about number 10? Xander?
I got it, I'll do it.
We already did it. We already did it. Okay, thank you though. All right, now number 11. Let's see if we can get this little word problem done. It's just like the one in the notes. So see if you can label those points. And then see if you can describe the
starting point, right? Well, no, maybe it is. Like, it's just that when I'm overthinking it. It's just probably
Okay, guys, we're almost out of time. Did anybody come up with any points? Any coordinates? Oscar, what'd you get?
I got 0, 0, then 2 and 20, 4 and 40, and then 6 and 20, and 0 and 2.
I love, or 8 and 0, you mean?
Yeah.
Yeah. Now, where did you put those points though?
I put on F, I put 0, 0, and then E, I put 8, 0, and then like G, 220, or, yeah, and then J, I did, farthest point 4, 40.
Okay, so let's talk about that for a second. Does that, I mean, I get your point, actually, that's not there. I get your points. But you said you put 0, 0 here and 8, 0 here.
Yeah.
And then this guy right here. So what did you say? It's got
I said that was 4 and 40.
Okay, so let's look at that. First of all, do his numbers make sense? Should he have a point that is 0, 0? Yes. And then he should have another point that's 8, 0. No question about it. Do you think he has those points in the right spots though? All right, we'll continue this conversation tomorrow. Have a good day. Homework is due Monday. 3.1 homework is due Monday.